Hi gang, this is number 3D from test 1. So for this one, I told you guys this was a special case, right? Because this is the greatest integer function, right? It's the step function, or some people call it the floor function. It always rounds down to the nearest integer. So this has an infinite amount of gaps on it. So if you're on the right side of the gap or the left side of the gap, your height is going to be different. Now this is your standard greatest integer function. It is shifted 3 units to the left. So just for those of you who are visual, so its first step has been, right, if you add something inside the function and it's a standard function, it's just going to push everything to the left. So this function, the first step is here at -3. If you need more details, I did this in lecture, so you can go over it there. I'll just review this briefly for the review of going over this test. But if you don't recognize this function at all, you should go look at the lecture. Okay, so I'm drawing this function so you guys have a visual of it. Okay, so what happens, oh, I'm all the way over at 4. Okay, hold on a second here. This is going to take me a little while to get over there. Okay, sorry, my steps were getting a little more longer as I was going through this, so let me just squeeze them back a tiny bit. Okay, so as you can see at 4, if I'm to the left of 4, I'm hitting this stair. If I'm to the left of 4, I'm actually going to hit a height of 6. If I'm to the right of 4, I'm actually going to hit a height of 7. So I had explained in lecture that for this particular function, it's highly sensitive, and you do not want to plug directly into it unless you're absolutely sure you know where the stair is. So I had asked you, if you're a little bit to the left, maybe plug in something like 3.9. So I had said, go ahead and plug in something. So like if you plugged in 3.9, so if you plugged in 3.9 and you added 3 to it, inside there it would have been 6.9. And since this is a rounding down function, that would have, it always rounds down. It's not like if you have a 0.5 you go up and less than 0.5 you go down. No, you always go down. You always go down. You go down to the nearest integer. So this ends up being a 6. It's a rounding down function only rounding down. And then this guy, if you're going to the right of 4, so something like 4.1, you want to stay like infinitesimally close, okay? Don't go like, if you put in a 5, you're too high. You want to stay really close to 4. So then if you had put in like a 4.1, that would have been 7.1, and when you round that down, it's a 7. okay? That's why these were 6 and 7. And then, therefore, just to go all the way with this now, therefore, if I had asked what was the two-sided limit, because on the left it's 6, on the right it's 7, that would mean the two-sided limit was D and E, because there's a gap at 4, okay? All right, gang, I hope that cleared up any problems on this one. I'll catch you in another video. Bye-bye.